moments in all our lives, especially when you're 50 plus years old, okay, where your childhood just gets slapped right back into existence. And as I'm watching season 5, which is the season that I'm on, I believe, of Master Chef Junior, these two characters come out of nowhere, okay? And I can't tell you how the chef, okay, all right, with the way he talks, just brings back that childhood memory, okay? He has always, besides him and Beaker, I think his name is Beaker, um, those two were always my favorite skits with the Muppet Show. And of course, Miss Piggy is classic, right? So, but nonetheless, um, I was like, you know what? Let me stop right there, okay, and finish this OSPF thing and be able to come back and enjoy this episode without having to think about OSPF. Okay, so what we're gonna do is we're gonna go into all these. Um, First of all, go back. Now, some of the commands, okay, that you put in do not have to be put in exactly with the no statement, okay? So I'm gonna say so I'm gonna say no IP OSPF 1, okay? All right, but with this particular command, okay, I don't have a choice. All right, so if I actually go in and I say VLAN 10 on a switch, okay, all right, to create the VLAN, all right, it's created, all right, and then I have to say no VLAN 10, okay, to get rid of that particular VLAN. I can't just say no VLAN, all right, okay. Now, if I go into a switch port and say switch port access VLAN 10, okay, all right, I don't have to say, because that takes out a VLAN 1 and puts it into VLAN 10, okay? I can say no switch port access, okay? And I believe I could just say VLAN. Um, I'm not sure. I would have to research that again. But there are certain commands where I don't have to do the exact entire syntax that I had to put to remove it that I had to put on there. So I just wanted to say that because I was thinking all I had to do was put no IP OSPF 1, but I still had to put in error 0. Okay, so that part is fine, and now we're gonna go into G2. Okay, but that's not all of them because and now so we're gonna say end show IP OSPF interface brief to find out which routers still have OSPF enabled on. Okay, and that's router 6, router 5, okay, and I think this is 5 and 6 because, oh no, router 2, okay, and router 1, okay, which router 1 shouldn't have done that. What happened? Um, oh, because this has a network statement. Okay, so okay, so now there we go, and let's go ahead and do that again. All right, so router 1, router 2, 3, 4, 5, 6, gone. Okay, they're all gone now. All right, so now let's actually minimize this, bring up this. Okay, scroll up, move over. All right, and now let's go ahead and take a look at router 1. Okay, now router 1, show IP OSPF. Okay, no interfaces. Okay, none. All right, so that means OSPF is not running on any interfaces in this topology. Okay, now I am going to create a loopback address, and I'm going to say IP OSPF 1, okay, area 0, okay. Oh, I have put so IP address 1.1.1.1 255.255. Okay, meaning that this is just the host address. Okay, so now, so show IP OSPF interfaces brief. Okay, so the loopback is there. Okay, all right, as an OSPF enabled interface. Now, show IP OSPF database. Okay, it's even in the database. Okay, all right, and it is as a router link state, okay, or as a LSA type 1, all right, LSA. Okay, so now we can't share this with anyone because we don't have an adjacency. Okay, so let's create an adjacency now, interface G1. Okay, and we're going to say IP OSPF 1 area 0. Okay, all right, and we're going to say IP OSPF network type point to point. Okay, now we're going to do the same thing for router 2. Interface interface G1. Okay, before I do that, I would say do show IP OSPF database. Okay, no database because there's no adjacency. So first of all, remember router 1 has OSPF only enabled on the loopback address. Okay, now and also on G1. So when I create the actual OSPF adjacency, configuration on G1, hello packets will be able to go back and forth, which 1 is already sending hello packets. Router 2 is not speaking OSPF now, so those hello packets are being ignored. So IP OSPF area 0, and then IP OSPF network point to point. All right. So now, show IP OSPF database. Okay. So now, okay, these are the interfaces. Okay. Okay. What am I looking at here? So hold on for a second. So 2.1 and 2.2. Okay, yeah, so those are our router interfaces. Okay, but okay, so yeah, so we got that here. Okay, all right. So look at what we're looking at here. All right, this is not a routing database. Okay, that's what our IP route is. Okay, this is a link state database, and what this is saying is I got this link ID and this link ID. Okay, all right. Now that means 2.1 is from router 1's perspective that it learned in 2.2. Okay? Alright? So we gotta look at both of these are the same. Okay, well what's the link ID? Well, first thing, I'm going to go ahead, I'm going to change router OSPF1, router ID, okay, 2.2.2.2, okay. I'm going to do the same thing over here. Router OSPF, router ID 1.1.1.1. Okay, now they both says please clear the IPS process, all right, to take effect. Okay, you gotta love these devices. All right, so clear IP OSPF. Okay, process done. Yes. Okay, now it's reloaded. So now let's go and take a look at show IP. Now, okay, look at that. 2.2 is the same. Wasn't expecting that, were you? Okay, because I got to clear the process over here too. I got to do it on both devices. All right, so clear IP OSPF process. Okay, now go back over to router 1 and now take a look at our database. Do you see how that works? Okay, this is why I want you to look at every router as a separate entity. Okay, the way these things behave. Okay, if I clear the process on router 1, it's bouncing the adjacency. Okay, so router 2 really should reset, but it isn't. The process itself isn't reset. The adjacency was bounced. Does that make sense? So I had to go over to router 2 and clear the process now. So now notice that still my advanced router and my ID, my router ID, are the same. Okay? Before it was an IP address. Make sense? Okay? Now, there's no loopback on the actual router 2 of 2.2.2.2. Okay? So the database, okay, is a database of the links, not the routes. Okay? And these are LSA type 1s. Okay? Because they're router IDs. They're talking about the router. Alright? So, from that concept, this is a link state protocol. So, what we're talking about is the links. Okay? And in theory, because technically the loopback address will be in there as well, right? Okay? But our link ID of 1.1.1.1 is in there and 2 is in there. Okay? So, now, let's go back over here. Okay, let's take this checksum here. Okay? Alright, we're going to paste it right here. Okay, so now if we take this and match it to this here, notice that 1.1.1.1's database that I copied from here is the same checksum as up here. Our databases are now synced with each other. Okay? In the OSPF area, everybody should have, okay, the same database. If that checksum is incorrect, well, we got a problem, okay, and we got to do some troubleshooting. So now I'm going to go into um, interface G2. Okay, this is an Ethernet link, so by default the network type is going to be broadcast, which it is a broadcast link. Okay, all right, so or that link is attached to a broadcast in the main, I should say. So IP OSPF area 0. Okay, and now go over to router 2. All right. Okay. All right. So this is going to take a little time to show IP OSPF neighbors. All right. Notice that it's coming up. It's stuck right now because it's going through its BDR and DR election. Okay. All right. Matter of fact, it's already done. Did it come up? Because I didn't see a console message. I mean, it says full. Okay. It's no. It's stuck in two way. There we go. I was saying I was looking at the wrong thing. Okay, so now we're up at full and I'm the DR. Okay, so for router one is the DR. So now show IP OSPF database. Now look at that. We have a router ID or a router link state, and we have a net state. The net state is the network. Okay, all right. So this is actually a layer 2 LSA. Okay? All right? Now, the layer 2 LSAs is doing what? It's talking about. Let's go back over here. We need to go back to our explanation here to make sure that we're 100% accurate. Okay, so here, all right, remember this, what we talked about last time. All right? So, the network 2, right, the network LSAs, all right, they're telling us who's the DR. And that's just kind of weird because I was expecting. Okay, did I read that wrong? Oh, I did read it wrong. Okay, so here's the neighbors. 2.2.2.2. Router 2 is a DR, not router 1. Okay, I'm sorry, I was reading it wrong. That's why I was getting a little confused there. Okay, so router 2 is the DR. Okay, all right, and your LSA type 2s are going to tell you which ones are the DRs. All right. Um, yeah, that was kind of blowing me. I was just like, but then again, hey, welcome to our world. This is what happens all the time. You know, you see something, you look at it, and you're not really reading it correctly. Makes your brain go a little crazy. But hey, um, we bounce back quick here. So let's continue on. So now we have now propagated two parts of our OSPF database. Okay? Now, what I want you to understand is this. Okay? All right? I'm going to go in and do this for the other routers. Okay? Config T interface G2. Okay? All right? And IP OSPF router ups IPS1 area 0. Okay? So that takes care of router 2, 3, 4, and 5. Okay? All right, and 5, I'll deal with that later on as we are going into 200. Okay? So now, as a matter of fact, let's go over to 5 now and get rid of. Okay, I don't think that's even there. So do show IP OSPF interfaces brief. Yeah, it's only G2, so it's not propagated wrong. So now, all right, because remember, once you add the process to the interface, like we did the loopback address, it goes in the database. So I didn't want G1 enabled in area 0, okay, because what's going to happen is that database is now going to put in G1 as area 0 as an OSPF router ID, okay, and I don't want that. All right, so uh, sometimes when you make changes on an OSPF router, okay, you can have convergence issues. What is convergence? Convergence means that I have advertised a route for on router 1, which is 1.1.1.1. And here's the problem. It takes time for me to enter that information as I hit the enter key to put it in the actual routing process. OSPF has to send out updates to every router or to the DR and over to the DR sends it all out. But it takes time, okay, whatever period of time that is, for Route 1 to be learned via OSPF throughout the other routers. So even router 6, okay, all right, router 1 is going to take some time before router 6 gets the route in its table, an OSPF route for 1.1.1.1. Okay, when all your routers in your domain or topology, okay, because this entire this entire diagram is our topology, okay, all right, it's our entire topology. Okay, now once all our routers get that information, that time it took to do so, that is your time of convergence. Okay, meaning that now once your network is converged, every route is reachable. You have full connectivity to all your routes. Okay, so now, take a look at this. All right, now again, it would have been nice if I changed the router IDs and cleared the processes on 3, 4, 5, but it doesn't matter. Okay, all right, but we're going to do that just to keep it uniform. Okay, so now let's go in and say config t. No. Clear IP OSPF process. All right, and say yes. Okay, so it's that simple because I'm doing it for all sessions. Okay, so now let's see if I can find my neighbor. Okay, so we're still stuck in our two-way states from our outer devices because of the um, DR and BDR elections. So we're gonna wait. Okay, there we go. Okay, there we go. And we got one more. Or do we? Oh, we got two more. Oh, okay, that's not gonna work. Okay, we gotta do this again. We actually have to go in and say um, router OSPF 1. Okay. Actually, no, we gotta go into config T OSPF 1, and then we have to say um, route IP. Oh no, we have to say router ID. Hit enter, so that command is going to be up there in our history. And now we got to go to 3.3.3.3. Done. for 4.4.4.4. Oops. Okay. 5. Okay. Okay, what's going on here? Okay, so let's make sure we got this. It's going to be number 3, 4, 5, okay, and then 6. Oh, why did it go in history? That's weird. For those last few routers. Not worrying about it, not concerned. Okay, so now, going back down to here, clear IP OSPF process. Yes. WR. Okay, so now. Okay, so now let's take a look at this again. Show IP OSPF database. Okay, we got 4 conversions. Okay, and this actually is still coming. Okay, and it's still coming. Oh, you look at the wrong one. You're looking at 6. I was like, why is it looking like that? Okay. Okay, so now that looks better. So let's clear the screen now by holding down the enter button. Okay, now this does look a lot better because you're using the router ID of 1.1.1. You know, okay, that 1.1.1.1 is router 1. Okay, so that looks a lot cleaner from a perspective of convenience as far as reading the actual database. Okay. Now, just because I use the same router IDs as I was a loopback does not mean that these are loopback addresses. These are router IDs. Okay? Alright, so that looks a lot better from the perspective. But in my database, it's telling you in area 0, okay, which is this, alright, that I have 1, 2, 3, 4, 5 routers that are in that area. Okay? So that shows me how many routers. So if I'm in production and I go and do this command, I got 30 routers in there, you kind of know that you got a large OSPF environment. Make sense? Okay, and it could be a lot more than that. Seriously. All right, depending on how large your enterprise is. So now, in area 0, okay, I have a DR, and that is the IP address of that DR. Okay, this is the router ID of that DR, which is 5. Okay, let's go to router 5. Show IP OSPF interfaces brief. Okay, that's, see, you're the DR. Now I can't do neighbors. Okay, because it's going to show me if it's a DR or a BDR from the neighbor's perspective. I have to actually use show IP OSPF interface brief to tell me what is if I am the DR. Does that make sense? Okay. So your neighbor command doesn't have 5.5.5.5 in there, okay, or the IP address of 2.5 because guess why? All right, because as your neighbor statements are here, your IP address is here. I don't have 2.5 because 2.5 is I am on 5. So I'm not going to have it in my neighbor statement. Does that make sense? Okay, so now, so far, let's take a look at this. Show IP OSPF database. Okay, database is the same. Okay, within my area. Now, I'm gonna go into router 5, G1, IP OSPF, network point to point, IP OSPF, 1, area 200. Okay, do show history. Alright, grab these two, or these three actually. Go on to router 6. Go ahead and paste that in. Alright, that just come up. So great. Okay, now let's take a look at router 6 database. Show IP OSPF. Okay, kind of interesting, isn't it? Okay, because we got information of area 0, but we also got information of area 0. I mean 200. So that means I have the routers that are in area 0, okay, which is, okay, what am I looking at here? Did I not change 4's router's ID? Yeah, I did. Okay, so la, 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 la. Okay, it's already set there. So let's take a look at this again. That's not exactly what I was expecting. Maybe again I'm reading it wrong. Okay, so let's make this large. Okay, so in our OSPF database, let's look at this at 5 first. Okay, let's do that first. Okay, so in area 0, okay, so you can see area 0, area 0, area 0, area 200, area 200. For area 0, here are uh, our router IDs, okay, as LSA type 1s. We have a DR election here, so we have a network type LSAs, okay. Now we have a summary here, okay. All right. Oh, I forgot about that. Okay. All right. Okay. That's why that was kind of blowing me. All right. So remember with the DRs, okay? I mean the not the DRs, the border area routers, okay? Or area border routers, okay? ABRs. Now, as we are going from one area to another, and remember, all areas must attach to area 0. Area 0 is your back. So if you have an area 100 in here, let's say the RIP area is area 100, set in this area like this. Okay, let's change this to, okay, area 100. Okay, here's the thing. And this is wild, so just hear me out, okay? Area 100 will never area 200 and vice versa. 200 will not exchange with 100 because it needs to be attached to area 0. If I just make this connection here, okay, now everyone converges. Everyone gets to know everybody because area 100 is now attached to area 200. Okay, think about your backbone. Okay, what's attached to that? Tons and tons of veins that spread out, okay, to your limbs. Your head's attached to your spine, okay? All right? Muscles are attached to your spine, okay? You got veins and nerves that are attached to your spine, okay? All right? So, you break those connections to your spine, it has nowhere to go because that it has no backbone to connect to in order to connect to other people. Okay, now remember, this is not how our backbones work, but you get the idea. Okay, so think about it that way. Okay, 100 in our scenario is not attached to area 0. So the only way for area 100 to work is to attach it to area 0 like this. Okay, and area 100 and area 200. This is how it works. Any routes in area 200 needs to go into area 0, okay? And because it's from a different area, it's going to be considered a summary route. And the only thing that we're advertising is the 3.0 network because that's the network that is being advertised once we enable it on router 5 as an OSPF process of 300. So now let's go over to router 1, 5, and 6. Okay. Okay. So now, see, here is our summary routes. 5 to 5 to 5 to 5. Okay. So what that tells you is this. Okay. As we are transferring routes from area 200 into area 0, they are becoming LSA type 3s, which are considered summary routes. In OSPF, okay, only on the area border routers where a router is sitting in multiple areas is the only place where you could do summarization. Now, here's the thing. You and I have never talked about summarization, so you don't know what that means, okay? But eventually we're going to get there, okay? But these are considered summary routes, okay? Now, some people look at this and say, well, why don't we have summary routes in area 200? Because the summary routes, like 1.1.1.1 that we have advertised on router 1, now becomes a summary route. Now, also the routes of 1.0, 2.0, and 4.0. Okay, and 3.0 is apparently missing. Okay, did I not? Yeah, it's missing. So we might have an adjacency issue with router 3, and we'll take a look at that in a second. Okay, but now the routes coming from area 0 into 200 is now a summary route. Any routes in area 200 coming into area 0 is a summary route. Any routes in area 1 coming into router 4, which we don't have to configure because the link's not there. Okay, we have that as a summary route. Okay, all right, and we can change this back to RIP. Okay, this can get confusing, and we're going to stop at layer 3. Okay, all right. From this example, okay, because as we look at this now, okay, just with the little bit that we have, this database is kind of complex. Okay, it could mess with you for a minute. All right, so that's why we did it the way we did it. This is how your database is built. Okay, and you still have other stuff. Okay, like your ASBR routes, which again we will cover in a different video. But still, at the same time, guys, this is how your database is built. And just what the topology we have now, it's a nice database as far as for you to get confused on. That's why we built it one by one. Okay? Now, if you look at this, it doesn't say LSA 1, 2, and 3. You have to know what router link means. Okay? And what network link states means. And what summary means. Okay? Alright? And we just covered the first 3 basic ones. Okay? Alright? And OSPF is very complicated. If you don't know how to read the database, okay, you're going to be weak in some ways. Now, you could log into 2 different routers and realize that this checksum is different. Somehow, some way, okay, the database did not get updated because everybody should have the same database, okay, that are in the same area. Don't get it twisted, okay? All right, so if we go on the router 6, okay, this database here, 64B, 64B, okay, is not going to match up, okay, because it's not, that's a directly connected link. Let's take a look at router 1. And I said that incorrectly. It's not because it's a directly connection link. It's not a, it's a router that's advertising that link, not receiving 1.1.1.1 as router 6 was. So show IP OSPF database. Okay, all right, and even though this is here 64B, it's not going to be the same. It's a different type of LSA. Okay, so the checksum is going to change. This is a summary LSA, so no way the actual the router state, okay, in that database is going to be the same. So you see my point? The database, it can be very complicated. You got to have your thinking cap on, and the only way to get used to this database is to learn it, okay, and lab it, okay, and get familiar with it. All right, you're not going to walk into a production environment and be able to use the database even with what I just taught you and be efficient with OSPF from a troubleshooting perspective. There's too many working parts. Okay, so learn your routing protocol. Okay, practice your trade and your skill set and grow it. Be determined. Be Cisco. But before that, be strong, be determined, be Cisco. Until next time, guys.